Hi, everyone. And let's have fun. Let's see the ways we can make fun of a REST API. Right. My name is Victor. I have 18 years of Java, of coding. I'm a Java champion. I'm doing workshops and consultancy for companies for more than 10 years in many, many, many domains that you can imagine, fintech, e-shop, telecom. And there's an animation not working over there. Yeah. There are 150 companies that I work with and you can find many of my talks on YouTube. I'm extracting from these workshops that I do every week. I'm extracting the things that the lessons learned, and I compile them in a talk like the one today. Good. I also have a community that I would invite you to join. It's called European Software Crafters. By the way, if you want the slides, you should scan this. I'm going to put it there for a couple of moments. So all the slides, it's a link to a Google Drive PDF that you can use afterwards to explore it more, like links, whatever, inside. Good. 3 more seconds. 2 more seconds. 1. Off. So, yeah, and I'm also trying to have a life. That's me over here in the corner, behind the girls. Yeah, anyway. So we're going to be talking about the REST API, right? So let's see what a co-author of TCP/IP protocol has to say about APIs. So we should always try to be conservative in what we do so that others can rely on us, but liberal in what we accept from others. We shouldn't be demanding much of others, but we ourselves should be backwards compatible. So let's play a little game to warm up a bit the brain. If this is a request that you receive in your REST API, and that's a response that you send back to your clients, what can you do what can you change in either the request or the response so that your clients must change their code? Think of, I want to hear you. What kind of change can you do in either the request form or the response so that your clients have to change their code? What could you do? Think of adding and removing a field, for instance. What can you do in the request that would cause a breaking change, that would force your clients to change their code? Sorry? Change the URL. Perfect. Make it in plural. What else? Come on, more ideas. What can you do in the request or the response so that you break your backwards compatibility? The format of the date. You, brother. What else? You make age a number. Why would you pass it as a string? All right? How about adding a new field in the request? Is that a breaking change? Only if it's mandatory. If it's an optional input, it's not a breaking change. How about adding a field in the response? That's not a breaking change. It's perfectly fine to add more stuff. What about removing a field? What about not supporting rubbles anymore? Why would you do that? I don't know. That's a breaking change, right? Whoever was sending you this will have a failed request now. How about supporting another country? And that's a fun one. That's an enum, right? If you add the value to an enum in your response, you breaking change your clients. If you add a value to an enum in the request, that is not a breaking change. So basically, that's all the things you can do. One fun is to rename a field. Why would you do that? You could create an array of phones instead of a single phone. Beautiful. You can turn a field that used to be optional into a required one. You could request a pattern for email, and you can have more fun with your colleagues afterwards on this slide. So these are the red ones, are the backwards, are the breaking changes to your compatibility. The green ones are. But the most important of all is that if you add an optional input and if you add an extra output, this is not a breaking change. OK? So it should be very clear. So what we're going to do in order to remain backwards compatible, we're going to keep adding more optional inputs and more outputs. So perhaps you're going to add tomorrow a phone string in your response. But it starts to get very mysterious when next to that attribute in your response, these two also appear. You see, it's the representation of the same information, but broken down in its two components, the country code and the local number. So you might actually see multiple representations of the same data in the same payload. Damn, that's not nice. But we do that to maintain backwards compatibility with what was exposed yesterday. Now, it gets very mysterious when this is not a response, but a request coming to you. And the request contains either the phone string as a single unit, either both of them. What happens if all of them come? It means there are two phones. It gets very mysterious. You see it? It gets very, very strange to interpret. And I'm not even making up these things. This is straight from an API of the Romanian government. Right? Multiple representation of the same things in the same payload. Why the hell? Because they want to avoid breaking changes. So this would pile up on you technical debt. Your API will be less and less clear for your clients. People are going to ask, what the hell? Why? Right? So at some point, you're going to draw the line, and you're going to make V2 and correct and repent and fix all this shit that piled up on your API. Right? So in the meantime, you're going to have to expose version 1 next to version 2. Who here has exposed more than one major version in production at the same time? Perfect, like half of you. Perfect. Now, what you do in V2, you could copy-paste from V1. Yay, copy-paste. Or you could put if statements in your core business logic. If V1, if V2. Anyone here has ever written if version equals 1? Beautiful, this is Sparta. Nice, nice. But then you should ideally have only two versions in parallel, right? Once you fade out V1, at some point only V2 remains supported, right? For a limited time frame. Good. Nice. This is the ideal, OK? So then you're going to have to hunt down who is calling the V1 API. Now, traditionally, we can do this by security tokens. Now, who is authorized to call this service? What GVT token? Who's the, right? Where does this request come from? But that might not always work. So my favorite is to use trace IDs. Who here is familiar with the concept of trace IDs in OpenTelemetry or in general observability? Right? There is this magic number that propagates with the headers of all the requests or messages that you send that you can then compile a view of where the requests came from to you. And you can just query the production last week to see from what system have I ever received traces, which is very fun, and it provides you the reality of yesterday, of last week. You might have a security token allowed to call you that no one used for 1 year. You wouldn't know. But the observability tells you who calls you last week, right? Nice. And then you have to convince V1 to upgrade. What you're going to do, you're going to call them, back them, kick them, not ship them any new more features, asking them to upgrade to V2. Make sense? But then you can rate limit them. You can increase your fees on version 1. You can force even a mobile app update. Ever seen a mobile app requesting you to update from Play Store? Ew, brother. Right? But then this is not all. Whatever you do, please don't do this. Please don't do this. Please don't do this. And don't pretend V1 has a vulnerability. It works. Don't do it. All right? So if you want to be kind to them, you should provide guides, even automatic recipes with open rewrite to help them migrate to V2, right? Or even you can take the way of the ninja and ask them, hey, can I help you? Do you want me to code with you? Right? Who is strong enough to do that, of course, right? This is the ideal world. The reality, however, talks about 7 parallel major versions for 10 years. I have clients in that hell, and they went to therapy. They went to therapy. Like what? They went to therapy. Life will never be the same, trust me, if you maintain more than 3 or 4 major versions in parallel. Can you imagine a bug fix? In all 4? Beautiful. So once you escape such a project, I promise to you that you will do everything you can never to breaking change your API. So what you're doing, you're going to make your API future-proof. Future-proof. Pay attention. Today you receive an email. But just in case tomorrow you want multiple emails, let's make it a list with exactly 1 element every time. You are forced to always pass a list with exactly 1 element. If you pass 2, 0, or null, it cracks saying wrong payload. You do this perhaps tomorrow. Or then you have a phone today, right? And just in case tomorrow you want to take different types of phone numbers, let's make an array which says this is the phone of type work. You always pass work in and out. But if tomorrow you want another type of phone, you have enough space to put it. Do you feel where this is going? Shit. This is... But you didn't see the best. Who here in the room has ever seen an attribute called metadata that can contain anything, any key with any value? Yes, true Spartans. Thank you. The name age value 12 is put in this random bag of attributes and values. And then more, you can have even substructures. Damn it. You see, with street and shit. All right. And then 50 more keys after several years. Beautiful. This is basically you giving up on using a schema. This is basically you saying no thank you to OpenAPI, right? Let them guess. Very evil, very evil. So with that, you just nuked your clarity. Everyone is going to wonder, what the heck is happening in this API? What should I pass? What should I receive, right? Now, how exactly do you version? Traditionally, I see this everywhere, like order service v2 order. You version at the root of your paths, basically. Please note this quote from the creator of REST. V1 is a middle finger to your API client, which warns them, oh, I'm going to screw you. This is just V1. Prepare yourself. Interesting. Then a more legacy approach would be to say /order/v2. I suspect there are multiple bounded contexts inside the same monolith over there. It's more of a legacy strategy. But the newest and shiny strategy is to create a completely separate microservice. Shit, do you see myself copy-pasting the old order service into order service v2 on a different Git? Damn, that's a lot of copy-paste. Right? Of course, at first you will connect them to the same database, but it gets very, very scary if you actually use two separate databases. That's no longer, that's a horror story not for today, right? But the point is that whenever you want to remove V1, it will be very easy, just destroy the Git repository, you take it from production, goodbye, right? So it's easy to remove V1. But I believe we all feel right now that every day that goes on with two parallel Git repositories with the same code base, 80% of it is the same, every day is a liability, is a risk. We have to kill V1 ASAP. Just don't tell them it has a vulnerability. Good. Now, besides this backwards compatibility, a more interesting question is how fast can you detect a mismatch in a contract? How fast can you detect when a contract gets broken? There are three things I want to share with you here. One is the following. You imagine, you know that Spring, for example, can extract from the actual code the OpenAPI from your Java sources, right? It tells you, here is your OpenAPI today in your code. Perfect. How about comparing the extracted OpenAPI with the OpenAPI saved on my Git since the last release? If the OpenAPI from my code is different than what I have stored on my Git, it means I broke my contract. Do you feel it? I broke it accidentally. It's like a fail-safe. Like, let's be sure we don't mess the contract up, right? That's a very simple test. If you click on this link in the slides, you're going to get to a GIST, which shows you how to do this. There is even a library that can help you with this, OpenAPI diff library. Now, a more delicate question is how do you make sure that the contract that you consume from them is in sync with the contract they provide to you? This is a very nasty problem because it involves different Git repositories. There are two solutions to look in here, Pact and Spring Cloud Contract. Both of them can fail a build whenever what you expect is not in sync with what they provide in terms of attributes, endpoints, and structure. Right? And the third thing I want to tell you is when you are fortunate enough to have a homogeneous environment, imagine that all the microservices in your ecosystem are all speaking Java. Lucky you. In that case, you can have a client library that most of my clients do this when they have a homogeneous environment. They ask their clients to import this library to call their API. But that allows you another trick. You can use bots, Dependabot and Renovate, that will continuously scan all the Git repositories to see whether there is a new version of the client library. And as soon as one is found, compilation is attempted, and if build succeeds, it will suggest a PR to your client project. it will suggest an upgrade of everyone. It's pretty clean solution, pretty nice solution. Some of my clients are using this with great success. Right, so that's about detecting contract mismatch. Huh? Now let's have a word about performance, and I want to have fun with you guys. If you have a lot of data in your storage, millions of items, millions of rows in a database, and you expose a get by ID like this, what can possibly go wrong? You have millions, and you only expose this. A timeout? No, but you get one product, and you have 10 million products in your database. Someone can do a query, a for loop, and in the for loop, machine gun your API. Do you see this? We call this performance massacre. We are paying the network latency repeatedly in a loop. This is a crime for performance. How do you fix this? How do you fix this? Expose an API that takes a page of IDs. Perfect, there you go. You get a product, question mark, ID, 1, 2, 3, 4, 5, 6. Perfect. Now, the problem with this approach is that most proxies will truncate the URL after 2,000 characters. So you can only put a number of IDs until you remain without, there's a cap to the maximum URL size. So why not using a post? A religious priest would say, are you using a post to retrieve data? Post should be creating. So what? Sue me. But still, it's a post, right? And you can put in the payload all the IDs you want to retrieve. Perfect. And then do you notice there are 100,000 IDs? What the hell is wrong with you? 100,000? Can you imagine the payload coming back to you? Like, the sky turns black and the response, 1 gig coming to you, out of memory. Game over. Yay. Nice. So you should impose the maximum size to the number of items. Usually 1,000 is a good starting point. How about putting that payload, that request body, in a get? How about doing that? When I went to school, I was told that get doesn't have a body. Did you went to the same school? Yeah? Well, they changed their mind. 4 years ago, someone came in the dark of the night and changed the standard, so get can now have a body. However, Azure, I heard, is not very happy you to send a body in a get. Or some other intermediary machines might truncate, discard the request payload. So it's not yet safe to use across the internet, right? For sure. So that being said, I will use the post. Good. Now, what happens next? You create this batch API, very nice, but your clients are still using the get by ID because that's what they've been doing forever. How do you convince them to move to the batch API? You what? You? How do you convince them? You return them, you rate limit them. You tell them, please use the batch API. Right. And you know what they do? True story. I swear to you, true story. Done. I use the batch API. Yes. I send batches of one element in a for. So, of course, you're going to rate limit the batch itself. What happened? Good. You're going to rate limit the batch itself, right? So, but that's the way to do it, right? Right. Now, I used to recommend people to implement such a bulk retrieve from day one when they knew they had a lot of data, but I changed my mind with years, and I'm now suggesting that you set up the necessary metrics and alarms in production that will tell you when someone is abusing your API. And when someone is machine gunning your API, you then implement this batch API, right? So it's about monitoring, about observing, yeah? If you don't know what I'm saying, there is a Dynatrace booth right here. Good. All right, another question you need to ask at this point is basically why, one second, is why are they calling, something is really strange here, my slide got truncated somehow. Anyway, that's a strange one. Now it's better. Another idea is to ask, why are you downloading my database? What are you doing over there with these thousands of elements? What business logic are you implementing? What you're doing over there is not by any chance my own business logic. Why are you downloading tons of my data on your side. And even worse, why are you doing it synchronously? Haven't you heard of Kafka? Or some other mechanism, CDC, to replicate my data to you asynchronously, not with machine gunning my... What happens over there? So I'm going to be kind to my clients and ask them, what are you doing over there, right? Good. Now, there is another fun discussion here, ideas of this form. And then there is a pen tester, a penetration tester, testing your application. What do you think they're going to tell you when they see you're using sequential IDs? Go negative? They will try -3, 404. What is wrong with sequential IDs? They are predictable. Someone could actually a hacker could try to iterate them to check whether maybe they are lucky and they get access to something they shouldn't see. What do we do instead of sequential IDs when you send them over internet, especially? You use what? The one that you cannot scam, UUIDs, right? So as a good practice, that's less vulnerable in a sense. Good. Next discussion about performance is when you have a client over the seas, in a tunnel, in an airplane, that wants to use your microservices, and for that purpose, they call 2 APIs to do one task. What could you do good for them? Because there is slow network over here and super fast network inside your intranet. What you can do is to aggregate what they needed and provide a single consolidated response back to them. Make sense? Right? Pretty easy. Pretty easy. It's a simple system, just calls the things you need and compiles a response. Here you go. Now, you can do this custom-made with code, actually calling and combining the results, but then it turns into a political question. Who owns this thing? Is it the green team or the blue team who's responsible for that? Right? So it can be very tricky. It can be very tricky to actually maintain this on the long term. Now, in April, Netflix had in Java 1 their biggest, their yearly report of how they use Java. And they said over there that they actually gave up on using Spring. Can you imagine this? On using REST. They said, we will not use REST. And what do they do instead? gRPC and GraphQL. So another idea to put in the aggregator over here is to use GraphQL Federator that will compile automatically, and it will solve part of the problem for you, right? And you just expose your APIs, and they will combine the stuff. And instead of REST between their services, they are using gRPC today. That sounds very, very interesting, but there is a problem. Always remember, you are not Netflix. Right? Be careful. You could be tempted to say, hey, we're going to grow big, we're going to scale a lot, so let's do what Netflix is doing. Don't. You don't have their scale, so put it in your context, right? Very important. Nice. So that's what we talk about, like performance. This performance, right? Well, when people say scalability, we mostly mean this. We mean performance, latency, throughput, this kind of stuff. But in my workshops, we get to very confusing moments when someone uses scalability to mean scalability of complexity, like adding more features. Let's talk about this now. How can you design the REST API? What mistakes can you do when you design a REST API that would hurt your maintainability, extensibility, and basically adding features with time? This is your core domain model. Imagine the customer is what you have, your core data structure. Most of your business rules, the biggest part of your complexity, uses this customer. What is your opinion when you would see code looking like this? Ouch. Exactly, black screen. Now it's again truncated. Any opinions? What do you say about this? In your REST API, you take your core data structure involved in most of your complexity, and you put it as a JSON. Any feeling? Boo! Exactly. Caesar voting. Boo! This is bad. Bad because the moment you do this, your clients are going to get coupled to your internal model. And I've seen projects failing because of this. terrible failure, millions of dollars off the trash, because it was impossible for them to evolve the domain because there was a large swing application deeply, tightly connected to the backend, for example. Also, security risk. The phone might leak out. I know you know how to fix this. You can put a JSON ignore, but that's going to add more garbage, more formatting and presentation concerns to the one data structure that you care most about. It's dangerous. It's mess. Plus, it can turn into a performance goof if you're using ORM and you, by mistake, serialize a list of children that have their own children, lazy loading the whole universe. I hope you don't know what I mean. If you know what I mean, it's terrible. Is it fixed? Yes, good. So, of course, we expose DTOs in our REST API, of course, right? So that's one of the oldest design principles in computer science, to separate the contract, which should be well-documented, stable, and clear for my clients, from my internal implementation, which is free to evolve to make it, to simplify what I'm doing internally, right? Contract versus implementation. Do you want me to speak dirty to you? Of course you do. Of course you do. Do you remember those days? .h? Anyone has any memories, bad memories with .h? Let me give you another hint. .cpp? Anyone? Beautiful. That times, yes. Those times, right? So we concluded that we will use a DTO. Here we go. We have a DTO in the left. I apologize, the sound effects don't work today. It was a technical issue. I'm sorry. I'm going to try to do them myself, but it's not. You have a get inventory item DTO. This is a DTO, an ID, a name, a supplier ID, yada, 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 yada. And the same data structure you use to create the inventory item. Any opinions when you look at this? The same structure is used both to retrieve the item and to create the item. What's fishy about this exactly? What's wrong exactly in here? The ID. The first thing, the ID. Should the client create the ID? Well, if it's numeric and sequential, definitely not. It's a sequence or something from the database, so that shouldn't be here. Plus, status, really? The activation reason, I'm just creating it, damn it. Created day, created by, this is something that should be done internal by the server, of course. So there are fields which makes no sense when you create, but make sense when you return, when you retrieve. Perfect. So the clients will be confused, the server implementation will be confused, everyone will be confused. Don't do this. Create, of course, separate objects for a request and for a response, right? I met a guy that told me that if they ever see a class ending in DTO, they will directly reject your pull request. Please use request response. Done. OK. And when you're doing that, you can brag that you've done CQRS. CQRS stands for Command Query Responsibility Segregation. Please mind, we don't say separation. If you want to get more salary, you should say segregation. Do you feel the difference in salary? Separation, segregation. So command query responsibility, segregation. So then command are the flows that are attempting to change the data. The query are the flows that are retrieving the data. CQRS is here to say that it's OK to use different data structures for the two types of flows that we have in our application. So the problem that CQRS is trying to solve is the assumption that most of us do when we start working on an application, and we initially think of this application as a repository of data, as an Excel file that you can create, read, update, delete, or search. Right? This is the first starting assumption. We are building a repository of data. Yay! But then, as complexity increases, you're going to see that the read flows need to join, to aggregate, to fetch more data, to reformat in a different way specific for the front end. So you're going to be tailoring your response for the read flows, and you're going to be deeply concerned with latency and availability. You have to respond fast and be available 99999. Whereas the flows involving writes are mostly concerns of preserving data consistency, right? So CQRS just tells you that it's OK to use different structures for the two types of flows, create and query, right? Or change and read, basically. So how does this relate to what we did? We created two structures, right? One for creating, which is a command, one for reading, which is a query, basically, OK? So in the API between me and my client, I now have two data structures, independent of one another. You can use the same CQRS in the interaction with your SQL database if you're using an ORM. Anyone using Hibernate in the room? Hibernate GPA? OK. ORM. If you're using an ORM, it is recommended that you do not select full entities from the database when you want to search through a lot of them, but instead do this syntax, which allows you to fetch exactly the attributes you need. You don't want to fetch the entire entity. Make sense? You get only what you need. And by that, you optimize the performance of this retrieval, of course. But when you will change the data on the right flows, you are still going to use the entity model, which provides guarded constraints in ways to change the data. So we are using different data structures for the two types of flows in there. Now, as you grow more interested in higher availability with lower latency, you want to move fast and be super available, you're going to meet this line, the line of the strong consistency. If you really want to get faster and more available, you, at some point, will have to accept eventual consistency in your life. Anyone ever crossed this line? They wanted faster speed, you put a cache, a Redis, an Elastic, something, just to get faster. That's a very scary moment when you have another database over here, which is asynchronously updated from the write database. So this is the write database, this is the read database. And changes propagate from one into the other, right? The scary part is the async update part, which might fail, which might get, I don't know, for some reason, out of sync. So what I'm talking about here is using Redis if you want super fast access, Elasticsearch for full text search, Mongo, or other specialized databases for different purposes, right? This is all CQRS done in a distributed way, or at least async. And I have a good old friend I want to remind you of. Have you ever heard of materialized view? It's the same principle. You pre-aggregate the data for some other flows every now and then. Beautiful, beautiful. So this is CQRS. I'm not going to go more into that detail, but as an overview, CQRS in the API between me and my database, or actually using two different databases for the two purposes. So CQRS is to separate commands from queries in terms of data structures, right? We have one structure to read, one structure to change, to write. Speaking of that, should the put return data? Have you ever seen a put which has a response that brings data back to client? You've seen it. Why? Why would you put? It's supposed to change the server state. Why would you return data to the client? And they tell me, for client convenience, we return enriched data. Guys, again, put is supposed to overwrite the state. Huh? And now the put brings back a response? Why would I bring back a response? I'm trying to write. You could be religious and say you are violating CQRS. But let's not be religious. Let's think, what happens if you do that? Now there are two ways to retrieve data, through get and put. Suddenly you have a coupling between the two responses, right? Suddenly you might leak sensitive data, and I can't tell you much more, but I have a client that had a production security vulnerability, which was exploited in production, and they lost millions of patient IDs, patient phone numbers. It's absolutely insane. So someone actually abused this to download the database. Like, absolutely insane. So don't do this, 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 unless to avoid delay reading your own write race condition in async CQRS. Not sure if you understand what this means. You just updated something, but the screen doesn't show you that if you search again. So in that circumstance, you might convince me to accept you to return data from put. You have to shout. The pause. to return data in your post. Like here, the ID doesn't count. Of course, you have to tell the guy the ID you generated, but that doesn't count as data, really. This is just the ID I've made for you, right? It will be really strange to mirror back the data to the client. Here, this is what you gave me. Don't do this. Generally, don't do this, unless there is some asynchronous race you want to avoid. You need a very strong ADR, architectural decision record, to convince me to return data from put. Put should be just changing. Make sense? It's a command. All good? Now, let's edit the inventory item we saw before. You have this edit form. Have you ever built an edit form? Edit? You change stuff, and then you say update. Beautiful. Now, tell me, what do you think is wrong in this screen? Anything fishy in this screen? I have a name, a description I can change. I have a supplier I can change from a list. I have a cost, stock, status, and deactivation reason. Anything stupid in the screen, please? The status? The status is active, but the deactivation reason is here. Wait a second, it's active. Why do you see this? It's very easy to fix, right? With a bit of JavaScript, with a bit of CSS, you can actually fix this. But how about the stock? What's wrong with the stock? So you're perfectly right. The first problem is that this shouldn't be here. But tell me more about the stock. What's wrong with the stock? I have stock 10 in my screen in an input text. What's wrong? Well, we have some validation. You cannot put letters. There will be validation. What else is wrong? Concurrency. There can be simultaneous requests selling an item from the database. So while one user changes the description, another customer buys an item from the stock. So you have 9 items in the database left, correct? What happens when you click update? When you click update, you can become famous. You can go to press. There can be articles about Victor that messed up the stock levels for the company for 6 months until he got fired. You can get to press for this. It's fantastic. It's an opportunity. So yes, the worst thing you could possibly do is to have to take this 10 and just overwrite the data from the database. That's absolutely outrageous. Okay? So you can't do this, but one fast trick would be to send the delta. How many do you want to sell? 3. OK, so you're going to send the delta of 3, and basically you don't claim to keep track of exact stock levels. Make sense? You say, what are you trying to do? Sell 3. OK. But there are other solutions to this same problem of concurrent updates of data in the database. One of them is called optimistic locking. You can display when they click update, you can tell the users, someone else already changed this item. Sucker was faster than you. Please refresh the page and redo updates. If you really want to get the user to a climax of despair, you refresh the whole page, not allowing them to copy any of their changes for maximum frustration. Yes. All the users will come to you and hug you. Yes, beautiful. You know the drill, right? With version column in the database. Long story, I'm not going to waste your time. But the other solution is to say, hey, you can't even click the edit button because this guy is editing this item since 3 hours ago. He's a French guy. He went to lunch. Good. This is much more expensive to implement. Huh? You have to keep track of who, when. You have to have a watchdog to release the lock after 3 weeks. Just imagining. Good. Good. Makes sense, this? It's optimistic, pessimistic. But there is another way to see the whole story. You could just look at what you're trying to achieve and just basically care for the users. Sit down with the users and see what they are doing with your application. They are usually editing name and description, or they are changing the supplier or the cost, or they are selling over the phone, or there are typical user actions they do. So what you can do is to rethink the user experience and create basically features, user interface components for their typical actions. So this is called task-based UI, or a better name I find is action buttons over edit screens. These are just buttons that if you click on this button, this is a checkbox. If you click on that checkbox, it's going to pop up a dialog asking you, you want to disable this item? Tell me why. Give me the reason for disabling this item. So it's designing the user interface by the actions that you see your users are typically doing, right? If you click here, you're going to edit the cost. If you click on the minus, it means you're trying to sell some items. And if you click here, it means you want to change some details about the product. You're going to have different views about the data, which is very nice, right? It provides a better user experience. It provides a more semantic API. Suddenly, the REST API tells what the user is trying to achieve, right? You are trying to put the details, and you are trying to put the cost, right? Lower concurrency risk, there is still concurrency risks, but much lower because stock, which is a highly volatile piece of information, is never displayed in a screen along with other piece of information which is less changing, which is more stable, right? The problem is you need to care for the users. You need to sit with the users and watch the user work, click through the interface, which can be tricky sometimes. So you don't have access, I don't know. Other problem is that it results in much more APIs. And there is a fine line between creating super narrow APIs and it's need to balance them. And also, you need to create more front-end. And if you are not a full-stack team, and if you have to ask to the front-end team to do it, you won't ever do it. They will tell you why. So if you are full-stack, you can take the problem and solve it yourself. Makes sense what you see here? Like actions which are modeled in the user experience, basically. Now, this made perfect sense, I believe, right? To change the details, to change the cost. But what is this? Is this an action? Ooh, it's a put to deactivate, providing the reason why you deactivated. And as well, this one. This is an action. I am selling. Wait a second. Is that a verb? Is that a verb in the URL? And by the way, why post? Because it's not idempotent. You can make it idempotent by including an idempotency key in every retry, but that's another discussion. For now, I want to draw you about verbs in the API. And as we know, thine URLs shall never contain verbs, said the REST priest. Have you ever heard this story, that your URLs should never have verbs? They lied to you. In the past, there was this, I don't want to completely destroy this, but let's look at the alternatives. Delete item activation. I am deleting the activation. And the second one, put status, and only if the new status is inactive, you shall provide the activation reason. For any other status here, this shouldn't be in there. How would you explain this? I know, you put a comment in the open API. Beautiful. So this sucks, right? That's why in this particular case, verbs are much more natural to use. So guys, I don't want now to start to push you to use verbs everywhere. No, you will stick to nouns until they seem to limit your semantic, until it feels awkward what you're trying to explain, like delete, activation, what the hell, right? Patch, exactly patch. But first of all, segregate unrelated client actions in different screens. Segregate is the keyword, yeah? Remember. And you said, let's use a patch. For guys, who here has ever used a patch, HTTP patch? HTTP, that half, this entire half has used a patch. Beautiful. So if you patch an item, you're going to provide some attributes which are the new values to set. You're going to provide some attributes which are set to null. And the rest of the attributes that don't show up in the payload are going to be left unchanged. Good luck parsing this payload with Jackson. If you parse this payload with a typical framework, there is no way to distinguish between a missing field and a null field. That's, of course, unless you're using JavaScript. But if you're using Java, Scala, Kotlin, any decent backend, it's going to be tricky to distinguish between the two. So that's why we should probably be using JSON patch, which says what path in the JSON is set or removed, right? And that there's a accompanying library that's what you meant by patch, I believe, I hope. This. Now, what's wrong in this picture still is that I cannot tell the meaning, the intent of the client. Let me give you another example. Have you ever seen a Git commit touching 300 lines in 20 files and having a commit message of did good? Ever seen this? Like, did good, yes, refactoring, exactly. What is the intent of the developer? What was he after or she after? What's the purpose? With a patch, you have the same problem. You cannot tell why did they change status, deactivation reason, and description. What's the point? What is the intent, right? So apparently, it seems like a good idea. Plus, the server code can look this shitty. You could create the new entity, fetch the old from the database, and then start comparing. Was it active and went to deactivated? Then, this is called reverse engineering the user intent. What the hell did they change in there, right? So it's hard to tell. I'm not completely against patch. You can convince me, but usually you know when it makes sense, when the server doesn't enforce any validation, any business rules about the data. When the server just stores that information and then sends it to somewhere else. If you do any kind of if statements, business logic, I'm not going to use patch. I'm going to create APIs that tell a story. And then the new age, I'm going to document that for, what's the name? Model Context Protocol, MCP. And then AI will take over the world and use my APIs very well. Research about MCP. Good. Now, this JSON that you change randomly, it's better to be stored in a Celob or a Mongo, because you don't have any rules. You can just take the JSON, put it in there, and there you go, right? Ever had a 500? So you get a 500 internal server error, and then you look in the payload, and the payload says, illegal argument exception, missing email. What is wrong in this picture? The stack trace. Like, what the hell is going on? Yes, that's completely wrong. It provides the hackers a way to determine your libraries and versions, and then they can attack you on your vulnerabilities, of course. So you should return a UUID back to the client, and then log the exception nicely into your log. Fun. But then, do you notice that this is a missing email? If it's missing email, why isn't a 400? Should be a 400, telling the user that you're missing email. So the user fills the email in their request, calls your endpoint, and you tell them you are now missing the phone. They put the phone and they are saying, hey, you're missing the age. And then your user grows frustrated, takes an axe, and kills you. Game over. You should, of course, return all the failures in one single go. There you go. Did you know that there is a standard that specifies how your response should tell what's wrong with the payload? Anyone using this standard? Like 7 hands in the room, therefore it's not a standard. But it's a good idea to, the path, interesting. Good, so, summary. Who needs backwards compatibility? Why? Your clients should be agile, right? Should adapt. You just nuke them, and they should adapt. It's a good test for the agility of your enterprise, right? How many days are they down when you change your contract? Guys, I want to be sure. Encourage your clients to call your get by ID in a loop. Why? Because that's how you take more traffic, and when you take more traffic, you need more instances in production, and then when they pay $10,000 per day for operating production, you can ask for a raise of salary because you work on such a hot production system, right? It's very good. Why should I hide my internal domain model? Is there anything to be ashamed of? Serialize it to all, JSON to all my core domain model. And if you create a DTO, you don't want to create more mappers, do you? So create one DTO and use it everywhere. Doesn't matter, half of the fields are null. Recycling, I mean, we want to recycle, right? We are, ecologically speaking, we want to recycle bytes. It's very important. Make penguins happy with this. Every put should return enriched data because you want to be nice to your clients, right? So give all the database in the put response. CRUD is all you need. Burn any verbs, and if you find anyone proposing a verb in a URL, burn him. Inquisition, and then burn the guy. Simple. One patch to rule them all, exactly. Why should we bother? A get, a patch, done. Done. Yeah, but the patch implementation has 10,000 lines. I don't care. It's a single endpoint. It's simple. Errors don't happen. Why bother, right? So, guys, these are the pitfalls of REST APIs. I hope you took something out of it. I thank you very much for your attention, and I wish you a wonderful conference and lunch.